For most of human history, the night sky has been a symbol of calm and beauty. Yet hidden in that darkness are ancient travelers of stone and metal. They are asteroids, silent and cold, drifting between planets. Most are harmless, but a few are large enough to change the fate of our world in a single impact. One strike could set the oceans boiling, darken the sky for years, and erase entire species from existence. But what if these same asteroids are not only a threat, but also a promise? What if the rocks that could destroy us also hold the key to our survival beyond Earth? Inside their frozen surfaces lie water that can be turned into rocket fuel, metals more valuable than gold, and clues to the origins of life itself. This documentary will explore how asteroids could bring both destruction and salvation. We will uncover how they formed, why they sometimes strike planets, and how one impact ended the reign of the dinosaurs. We will see how scientists search the sky every night, racing to find the next potential threat before it finds us. We will study missions by the National Aeronautics and Space Administration and the European Space Agency that are trying to push an asteroid off course. For the first time in history, humanity is learning how to defend itself against a cosmic disaster. But this story is not only about survival, it is also about opportunity. Asteroids are rich in iron, nickel, platinum, and water ice. They could fuel spacecraft, build space stations, and support human colonies far from Earth. Some scientists believe that the first trillionaire will not be someone who owns land or oil, but someone who owns a mining operation in space. So, are asteroids our greatest danger or our greatest hope? The answer lies in the choices we make now. This is the story of ancient worlds floating in silence, and the future of our own. This is how asteroids could destroy or save humanity. Before we can understand how asteroids could destroy or save humanity, we must first understand what they truly are. Asteroids are not just space rocks drifting without purpose. They are time capsules. They are leftover pieces from the birth of the solar system, more than 4 billion years ago. Billions of years before Earth had oceans, trees, or humans, clouds of gas and dust swirled around the young sun. Most of this material clumped together to form planets, but not all of it found a home. Some fragments never merged into worlds. They remained small and scattered. Today, we call these fragments asteroids. Most of them orbit the Sun peacefully between Mars and Jupiter. This region is called the asteroid belt. It holds millions of rocky objects, from tiny pebbles to worlds nearly the size of small planets. The largest of them is Ceres, a dwarf planet almost 1,000 kilometers wide. But not all asteroids stay in the belt. The pull of Jupiter's powerful gravity can disturb their orbits. Over millions of years, some are pushed inward toward the Sun, crossing paths with Earth. These are known as near-Earth asteroids. They are the ones we must watch most carefully. Asteroids are made of different materials depending on how they formed. Some are dark and rich in carbon. These are called carbonaceous asteroids. They are some of the oldest objects in the solar system and may contain water and complex molecules, the same ingredients that helped life begin on Earth. Others are made of stone and metal. These are the building blocks of planets, and a rare few are made almost entirely of iron and nickel. They are incredibly dense and harder than steel. While most asteroids are cold and silent, they are not dead. Some release gas and dust when sunlight heats their surface. When this happens, they form a tail and begin to resemble comets. This shows that some of these ancient bodies still hold ice, locked deep inside. Asteroids are powerful reminders of where we come from. They are the broken pieces of worlds that never formed. They are the storytellers of the solar system's violent past. But they are also travelers, moving across space in silence, sometimes toward Earth. They are older than any mountain, any ocean, or any species. And yet one of them, on one wrong path, could change everything in a single moment. 66 million years ago, Earth was a world ruled by giants. Towering dinosaurs walked through forests and swamps. Flying reptiles soared across the skies. Oceans were filled with monstrous predators. Life flourished in incredible forms, but all of it would change in a single day. A massive asteroid, around 10 kilometers wide, was traveling silently through space. No sound, no warning. It crossed Earth's orbit and entered the atmosphere above what is now the Yucatan Peninsula in Mexico. In less than a second, it struck the planet with a force greater than billions of nuclear bombs. The impact created a crater over 180 kilometers wide. Rock and molten material shot high into the sky. The ground melted and vaporized. Everything within thousands of kilometers was instantly burned or crushed. But the true destruction did not end there. The asteroid threw enormous amounts of dust, ash, and sulfur into the atmosphere. This formed a thick layer around the globe, blocking sunlight. Day turned to darkness. Plants could not perform photosynthesis. Temperatures dropped, forests died, oceans cooled and became acidic. Wildfires swept across the continents. Toxic rain fell from the dark sky. Food chains collapsed. Animals starved. Most of the dinosaurs, along with 75% of all species on Earth, vanished forever. Only smaller, adaptable creatures survived. One small group of mammals would eventually evolve into humans. This event is now known as the Chicxulub impact, named after the crater it left behind. It is one of the most powerful reminders in history that Earth is not isolated. It is part of a much larger cosmic system. A world can change not in centuries, but in moments. Scientists discovered the evidence in the late 20th century. They found a thin layer of rock across Earth, rich in iridium, a metal rare on Earth but common in asteroids. Beneath the surface of Mexico, they found the enormous impact crater hidden under layers of sediment. The story of the dinosaurs is a warning. Asteroids have shaped the history of life on Earth. They will shape the future as well. The same kind of impact could happen again. But only if we are unprepared. Every night, countless rocks drift through the darkness of space. Some are small as a grain of sand. Others are mountains floating in the void. Earth orbits peacefully around the sun, but it is not alone. It travels through a cosmic shooting range. The truth is simple. Yes, an asteroid could hit Earth again. The only question is when. Astronomers estimate that more than 25,000 near-Earth asteroids are large enough to destroy an entire city. Over 1,000 are big enough to wipe out an entire region. A few, though rare, could end civilization. These are called potentially hazardous asteroids. They follow orbits that bring them close to Earth's path around the Sun. Fortunately, scientists track most of the large ones. NASA's Planetary Defense Program, along with observatories around the world, scans the sky every night. They map objects, calculate their orbits, and predict future positions. But there is a danger hidden in the numbers. We have only discovered about half of the asteroids larger than 140 meters. Many more remain undetected, especially dark ones that do not reflect sunlight. Some approach from the direction of the sun, making them hard to see until it is too late. Recent history proves that impacts still happen. In 2013, a small asteroid exploded in the sky over Chelyabinsk, Russia. It was only about 20 meters wide. Yet the blast shattered windows, injured more than 1,000 people, and created a shockwave equivalent to a nuclear explosion. In 2008, an asteroid the size of a car burned up over Sudan. In 2021, a large asteroid passed closer to Earth than some satellites before astronomers even noticed it. These were small, but if a rock 1 kilometer wide struck Earth, the damage would be global. Firestorms, tsunamis, a sky filled with dust. Crops could fail. Millions could die. This is not science fiction. It has happened before. It will happen again, unless we prepare. For the first time in history, humanity has the knowledge to see the threat coming. The question is whether we will act before it arrives. For the first time in human history, we are not helpless. We can detect asteroids, track them, and even change their path through space. Saving Earth from a cosmic disaster is no longer imagination. It is becoming science and engineering. The first step is early warning. Telescopes like Pan-STARRS in Hawaii and the Catalina Sky Survey in Arizona scan the skies every night. NASA is also planning a new space telescope called the NEO Surveyor. It will orbit the sun and look for dark asteroids using infrared light. The sooner we detect a threat, the more options we have to stop it. The second step is deflection. Scientists are testing different methods to push an asteroid off course, just enough so it misses Earth. One method is called a kinetic impactor. It is simple and powerful. A spacecraft crashes into the asteroid at incredible speed, like a cosmic cannonball, and the force changes its trajectory. In 2022, NASA proved this idea with the DART mission. The spacecraft slammed into an asteroid moon called Dimorphos and successfully changed its orbit. It was the first time humanity altered the motion of a celestial body. Another idea is the gravity tractor. A spacecraft flies next to the asteroid for months or even years. Its gravity pulls gently on the asteroid, slowly shifting its path. It is slow, but extremely precise. This method could work for smaller asteroids detected decades in advance. There are also more extreme plans. Some suggest using lasers powered by solar energy. Others propose covering the asteroid with reflective paint to change how sunlight pushes against it. Nuclear devices are considered a last resort, not to destroy the asteroid, but to detonate near its surface and nudge it off course. Every method shares one rule. The earlier we act, the easier it is to save the planet. But planetary defense does not end with technology. It requires global cooperation. Asteroids do not belong to one nation. If one threatens Earth, every country is at risk. That is why the United Nations has created groups like the International Asteroid Warning Network. Their mission is to share data, coordinate response plans, and ensure that, when the time comes, the world will act together. For the first time since the age of dinosaurs, Earth has guardians. Asteroids are not just destroyers. They could also become saviors, unlocking a new age of technology and exploration. What once threatened life on Earth could one day sustain it. Many asteroids are ancient leftovers from the birth of the solar system. They contain metals like iron, nickel, cobalt, and even precious elements such as platinum and gold. Some hold water ice, carbon molecules, and minerals that could support future space colonies. These are not just rocks in space. They are flying treasure chests. A single metallic asteroid measuring only 1 kilometer across could contain more iron and nickel than humanity has ever mined on Earth. Some rare asteroids could even be worth trillions of United States dollars in precious metals. But the true value of asteroids is not wealth. It is survival. In the future, if humans build settlements on the Moon or Mars, they will need water, oxygen, and fuel. Asteroids could supply these resources. Water from space rocks can be turned into drinking water, breathable oxygen, and rocket fuel made of hydrogen and oxygen. This could turn asteroids into natural gas stations in space. Mining asteroids is difficult but possible. Robotic spacecraft could land on the surface, drill into the rock, heat materials to extract water or metals, and send them back to orbit. Companies and space agencies are already designing systems to make this vision real. NASA's OSIRIS-REx mission visited an asteroid called Bennu and brought samples back to Earth in 2023. It showed that collecting material from an asteroid is not just theory. It is reality. Other missions, like Japan's Hayabusa probes, have done the same. Asteroid resources could also help fight climate change on Earth. Instead of mining forests and mountains, we could gather materials from space without damaging our planet. Clean energy satellites built using asteroid metals could one day beam power down to Earth. But space mining is not just science. It raises questions about ownership. Who controls space resources? Who benefits? International laws must evolve to make sure space does not become the next place for conflict. Asteroids are a paradox. They can wipe us out, but they may also help us survive. They are both danger and opportunity, destruction and hope. To understand why asteroids must be taken seriously, we only have to look into Earth's past. our planet carries the scars of ancient impacts. Some change landscapes, others change life itself. 66 million years ago, an asteroid about 10 kilometers wide struck what is now the Yucatan Peninsula in Mexico. The impact released energy equal to billions of nuclear bombs. A crater over 180 kilometers across, called the Chicxulub crater, was formed. In an instant, forests turned to fire. Mega tsunamis raced across oceans. Dust and sulfur filled the atmosphere, blocking sunlight for months, maybe even years. Plants died first, then herbivores, then predators. 75% of all species vanished. This was the end of the dinosaurs and the rise of mammals. Without this asteroid impact, humans might never have existed. This was not the only time. 2 billion years ago, a massive asteroid struck South Africa, forming the Vredefort crater. 1.8 billion years ago, another created the Sudbury Basin in Canada. These impacts shaped continents and altered the evolution of life. Not all strikes are ancient. In 1908, a mysterious explosion flattened over 2,000 square kilometers of forest in Siberia. No crater was found. Scientists believe a small asteroid, about 50 meters wide, exploded in the atmosphere. This event is known as the Tunguska event. More recently, in 2013, a 20-meter asteroid exploded above the city of Chelyabinsk in Russia. The blast shattered windows across thousands of buildings. Over 1,000 people were injured, not by the asteroid itself, but by broken glass and shock waves. These events remind us of a truth. Asteroid impacts are not science fiction. They are part of Earth's history. They will happen again. But unlike the dinosaurs, we have something they did not: technology, knowledge, and the ability to act before it is too late. For the first time in Earth's history, one species has the power to predict, track, and possibly stop a killer asteroid. That species is us. Today, scientists around the world are not waiting for the next disaster. They are building a planetary defense system. A shield made not of walls or weapons, but of telescopes, data, spacecraft, and human cooperation. The first step is detection. Telescopes like Pan-STARRS in Hawaii and the Catalina Sky Survey in Arizona scan the skies every night. They search for near-Earth objects, asteroids, and comets that could come close to our planet. NASA's Center for Near-Earth Object Studies keeps a list and calculates future trajectories. There are more than 30,000 known near-Earth asteroids. Most are small. Some are big enough to cause disaster. The second step is deflection. If an asteroid is found on a collision course years before impact, we may have several options. One method is the kinetic impactor. This means hitting the asteroid with a high-speed spacecraft, not to destroy it, but to change its path slightly. Even a change of a few millimeters per second, if done early enough, can nudge the asteroid away from Earth. This is not theory. In September 2022, NASA's DART mission, the Double Asteroid Redirection Test, successfully struck a small asteroid moon called Dimorphos. The collision changed its orbit. This was the first time humanity deliberately altered the motion of a celestial object. Another idea is the gravity tractor. A spacecraft would fly close to the asteroid for months or years. Its gravity, although tiny, would gently pull the asteroid off course. This method is slow but safe. Nuclear devices remain a last resort. They would not blow the asteroid apart like in movies. Instead, an explosion near the surface could vaporize part of the asteroid, creating a burst of gas that pushes it in another direction. Scientists are studying how to use nuclear energy carefully, without creating multiple dangerous fragments. The third step is preparation. Governments and space agencies conduct emergency simulations. They ask important questions. If an asteroid were headed for Earth, who makes the decision to act? Which country builds the mission? Who evacuates cities? How do we warn the world without causing panic? In 2029, a large asteroid named Apophis will pass so close to Earth that it will fly inside the orbits of some satellites. It will not hit us, but it will be a powerful reminder that we live in a cosmic shooting range. We are not powerless. We are learning. We are preparing. Each mission, each telescope, and each calculation brings us one step closer to defending our world. Asteroids are often seen as threats, pieces of rock and metal drifting in space, waiting to strike Earth. But what if they are not only dangers? What if they are also opportunities? Beyond their destructive power, asteroids could become one of the greatest resources in human history. Many asteroids contain valuable materials. Some are rich in iron, nickel, cobalt, and rare metals like platinum and palladium. These are the same metals used in electronics, spacecraft, batteries, and advanced technology. On Earth, they are limited. In space, they are floating above us in almost limitless supply. There are also water-rich asteroids. Inside them, ice is locked within rock. Water is more than something to drink. It can be split into hydrogen and oxygen. Hydrogen is a powerful rocket fuel. Oxygen is needed for breathing and for burning fuel. This means asteroids could provide fuel stations in space. Instead of launching everything from Earth, future missions could mine asteroids, process materials, and refuel ships in orbit. This could make deep space travel cheaper and faster. Space agencies and private companies are already planning for this future. NASA has studied missions to capture and redirect small asteroids. Private companies like Planetary Resources and Deep Space Industries were created to explore asteroid mining. Japan's Hayabusa missions and NASA's OSIRIS-REx have already brought back asteroid samples to Earth, proving that we can land on, collect, and return material from these distant worlds. Mining an asteroid is not easy. There is no wind, no gravity like Earth, and temperatures can swing from extreme heat to extreme cold. Machines must dig in weightlessness. Metal must be processed in vacuum. Water must be extracted from frozen rock. Robots will likely be the first miners. They will drill, melt ice, cut stone, and build storage tanks. Later, spacecraft may carry these resources to Earth orbit or to the Moon, where humans can use them. Why is this important? Because if humanity wants to explore Mars, build bases on the Moon, or travel beyond the solar system, we need resources. Bringing everything from Earth is expensive and inefficient. Asteroids may become stepping stones to the stars. Asteroids could destroy us, but they may also help us survive, expand, and thrive in space. It is a story of risk and reward. The same rocks that ended the age of dinosaurs could help begin the age of interplanetary humans. Asteroids are silent travelers. They do not shine like stars or burn like suns. They drift through the cold and empty darkness of space. Yet these small worlds carry the power to destroy civilizations or to shape the future of humanity. They remind us of how fragile life on Earth truly is. One rock from space changed the course of evolution and ended the reign of the dinosaurs. Another could do the same to us. But unlike the past, we are no longer powerless. We can detect asteroids. We can track them. And for the first time in history, we can stop them. But their story does not end there. Asteroids are not only a threat, they are also a promise. They hold metals that can build space stations. They hold water that can fuel rockets. They could become the foundation of a new space economy. A future where humanity is not trapped on one planet, but lives among the stars. How we choose to see asteroids may shape the future, as danger, as opportunity, or as both. This is not just a story about rocks in space. It is a story about us, about our survival, our curiosity, our courage to face the unknown, and our dream to move beyond Earth and explore the universe. The fate of humanity is not written in stone. It is written in the choices we make now. If we observe the skies, prepare for impact, and reach for the stars, then even the darkest threats can become bridges to a brighter future. If this journey into the hidden world of asteroids inspired you, make sure to subscribe. There is so much more waiting out there in the universe, and this is just the beginning.